This continues with the theme of rendering glass materials, but is also a bit of an advert for this product that Horror and I've made, this one, and it incorporates this HDRI made by Horror, which comes with this product along with 50 of these sort of twisty shapes and 50 metals that have sort of a special effect associated with them, or a great deal of them do anyway, which you will see because I'm going to show you some of them. So at the moment this is lit with default Bryce sky. The global shadow intensity is set at 100, and I've just moved the sun around a bit. These are default Bryce materials. What I'm going to do is modify the ground plane to start with, and I'm going to give it one of the very dark versions of this material, and it uses this anisotropic effect and what we know about metallicity and an extreme form of reflection used by out of range functions, and that creates this sort of effect on the ground. The important bit about this choice was that it doesn't have any diffuse response to talk of, so we don't have the problem with the shadows that we had in the last video. Right, for our group, which is this model and a default Bryce sphere, just so we've got some reference point, I'm going to modify the material for that to this red material that's got curvature control in, and this special effect comes out as a result of the anisotropic effect here, which is also applied using curvature. So it's a fairly complex material, and it also utilizes bump, so that could be quite punishing in terms of rendering it as a glass. Now you may have noticed, the more alert of you, that even though I've just said this is a metal material, we have transparency set, which might seem like an odd choice, and you might also be able to detect a bit of light coming through this. Now the reason the light's coming through this in the preview is that the preview isn't set at 100% shadow intensity. The shadow intensity setting for this preview in its default state is 90, even though we've got it set up in the world as that, so that explains some of the difference. I think you have the option of turning the render with neutral sky off, and then you'll see the state with 100% shadow intensity. I'll just turn that back on so you can see the difference. There you go. So that explains the difference there. And the reason that this isn't actually transparent when we render it is that I've set the transparent and volume colours to fully black, so that prevents any light from travelling through it, but we still get diffuse colour even though it's not diffuse, and that's coming through the metallicity channel. So to convert this to a glass, fairly easy. We don't need reflection. If we're not using reflection, we don't need metallicity. We do need the light to get through it, so I'm going to set the volume up to fully white, hold the Alt key down and click on there, and that swatch, and there you go, set it to fully white. We want the diffuse colour set to fully white so that that's not interfering either with the transparent transmission of light, and then holding the Control key down, click on the C blob, and then we can have those colours transferred to the transparent component. So that now affects the light that goes through the surface of the object geometry. One last thing to consider is I had the refraction set up, and the reason for that is because I was taking advantage of the grazing angle reflection that's provided automatically as a part of transparency. So I prevented the transparent transmission, but did have the grazing angle reflection set. But I don't need it to be that high, and I want the refraction to be around about that of a glass. So I set it down to 153, and therefore we've modified our glass material now to be our funky glass material instead of a funky metal material. Now if you just have a look in the default state how that looks. Okay, as I said before, a large component of the appearance of the glass is reflection, and more so if we set the render options and have total internal reflection set. So that was already set, that's not a default setting, so if you haven't set that, you need to set that. So with that setting now, we're getting more out of the reflections, and as a result we really want something more interesting than the default Bryce sky for it to reflect. So this is going to be the point at which I load the HDRI image, but before I do that I'm going to remember to turn the atmosphere off and set it to fully black. Then when I add the HDRI image in this background, which I'm about to do, image-based lighting, use HDRI image, open, medium resolution one will suffice because we've not got any direct reflection, and then add it to the sky. It'll just be adding to black, so the only effect that we'll get is from the HDRI image. Right, turn the quality down to 16, and at this point I'm going to remove both specular and HDRI effect and turn the intensity up to 10, so we've got something to work with the reflections. At this point, because the sunlight is disabled, the only thing that's being rendered in this scene now is as a result of reflections. So as you can see, it's all a bit dark. So what we can do to get around this is we need to lighten the model up somehow. In the last example I used ambient to light it up, but we can actually do better than that, and we can still stay fairly render efficient. We can use a trick where you use this control here and apply to light source and use that to multiply up the specular output of the HDRI image from the simulated light sources. But because we're only providing a kind of ambient light in the material, we can turn off cast shadows, which increases the render efficiency tremendously. You can see now it's going through like a dose of salts, and it's lightened up our glass material. So if I have a look now, it's looking quite a bit brighter. So the anisotropic effect is coming through generally through this material, lightening it up. We've got the transparency and the lightness is being seen through the material, but we don't really have any impact like we had before from the anisotropic highlight. We've got some nice reflections provided by the HDRI image, but we really want that highlight back in there. So just to do that bit, go into the Skylab again, re-enable the sun. As I suggested, we don't need any diffuse output, so we can just turn that down to 0 to demonstrate that. We're just using the specular and the specular highlight, and at this point we should be ready to roll. So that really, the bright strike across these edges is coming from the sunlight. The sunlight specular is casting a shadow, and it's debatable whether we need that even. We could turn off global shadow casting. It's a risky thing to do, but let's give it a shot. So at this point the highlight will get caught in other parts of the model, and as it did with the HDRI image, so we might need to attenuate it a bit. So just turn it down and see how those look. So if I just do that one, I just want it to go to fully white, so it's gone a little bit dim there. So I'll go back in here and turn it up, say, to 65, and then just render that a little bit again. So that's brought it up to full brightness. And then if we give the whole thing a render now, so the render time, it's only in seconds. We are dealing with a glass material, but because there's no shadow casting, it's so much more efficient. We have got the transparency, so you're seeing through different parts of it. But the only thing that's going to really slow things down is the anti-alias pass, and the reason for that is that the materials that I've chosen for this are quite noisy. They've got a lot of high frequency noise in them. This creates a nice effect in the render. Well, I think so, but as you can see, the resolution of the anti-alias pass it slows it down a lot because of the way that anti-aliasing works. You set a threshold level. The default level is set at 15. And what happens is that adjacent pixels are compared with one another. If those adjacent pixels are quite close in value, then there is no need to anti-alias them because your eye wouldn't be able to detect the difference. However, if you have pixels next to each other, like this very bright pixel next to a very dark pixel, at that point Bryce goes through an additional pass where it sends out more rays and investigates what's around that pixel and then adjusts the brightness accordingly. So if it really was a bright spot there and it was about the size of a pixel, then it would return a bright spot there about the size of a pixel. But a lot of these bright spots are as a result of very much smaller sizes than the pixel. But it just happens that when the ray went out and investigated the surface, it found a bright spot there and returned it for that value on the surface. There is a similar and related problem that occurs in rendering with true ambience, where you get what they call fireflies in the render, and these are bright spots that get scattered around and not resolved because they are so much brighter that no amount of having darker things around them will ever tone them down. This is an issue particularly with having high dynamic range images. If you imagine this bright spot, for example, although on the screen it only can appear fully white, in the HDRI image the value that's stored there is so much brighter than fully white, which means that if we were to put something in here that only reflected half the value, it would still appear fully white. And although this is a problem, it is a great advantage when using HDRI images as a backdrop, because it gives you far more faithful reproduction of the reflected background than you would get if you just used an image for the reflected background. Oh goodness me, I really went on a lot then, didn't I? Okay, so there you go. That's the end of the video. That's more or less the end of the render. I hope you found that interesting, and that you will, if you get this product, experiment with turning your funky metals into funky glasses.